Good evening, everyone. What I have for you this evening is a Canon PSD calculator. This is a relatively early, I'm thinking 80s, but we'll see, printing calculator. It's got nickel cadmium batteries. You can see that if calculator does not operate, turn the power switch off, then charge calculator several hours before using. So it's got a nickel cadmium battery pack in here. That's probably bad. I don't have the charger, but it says it's 3.6 volts. Well, that sounds like a nickel cadmium battery pack charger, 2.2 watts. So I don't have the charger, and I don't know how many cells we'll have in there. We'll see when we open it up and see what we've got. There are a few options we could think about for how to power this. This is all sealed. Looks like it's got 1, 2, 3 screws and 2 clips at the front to hold it together. It came with paper, which is good because I don't have this size. And the printing mechanism, if you've seen my other calculator videos, you'll know that I'm interested in printing mechanisms. Looks like it uses a standard reel, and it uses, look at, this is regular paper, not heat sensitive, not heat transfer paper. So nicely, we've got the whole thing here. It doesn't look like it comes off. Let's close that back up. I wasn't intending to buy this. Well, I picked it up and was thinking I would take it back because I didn't have a power supply. But then I found something else I wanted, and since I was carrying this, I bought it too. Looks fairly straightforward. Got a total, so it's going to be adding machine type logic functions, and yeah, it's really nice, and it's in beautiful shape. It was probably not pure white, but it's yellowed quite a bit, of course, but the Lexan here is perfect. Oh, and the other thing is it looks to be a vacuum fluorescent display in there. So what are we going to do? Well, I've wiped it off a little bit just with a damp cloth, but what I'm going to do for the moment is open it up, see what the batteries are. There's no indication of polarity on this. I would bet it's center negative from this era, but doesn't say here. And then I'll have to figure out some sort of power supply to get it going. You never know if the nickel cadmiums haven't leaked all over the place. They might hold a charge. The nickel cadmiums can be funny sometimes, but I doubt it. I'm going to remove these screws first. We may not need to remove that one, depending on how it's designed. Okay, I have it open. It was a question of getting into these clips in the side like a modern piece of electronics. So what do we see? We see a vacuum fluorescent display. That looks lovely. We've got the motor and the print mechanism. Actually, this one has multiple motors. This is considerably more complex, I think. Oh, is that a solenoid? Yeah, that's a solenoid. Do we have a date? No, I'm not seeing one yet. Oh, we've got a battery. Sanyo Electric Corporation. It is leaking, but it is contained within here. We've got 3 nickel metal hydride cells. Okay, so that's good. So we can probably remove that. I probably have another one of these, so we can maybe solder up a pack out of, these are AAA nickel metal hydrides, but they should be fine for this, at least to test it out. And we now have presumably positive and negative. They're probably marked on the board. Is there, no, this is soldered on, so we can't remove it. The electronics are in here, I believe. No? No, they could be underneath the mechanism. All right, let's have a look. Here's our plug. Can we lever that out? Not super easily. It's clipped in. Oh, here we go. It looks to be, assuming red is positive, it looks to be center negative like I presuppose, but I'm probably just going to solder a couple of wires onto there. I want to have a look at this battery pack. Can we remove this tape? Here. I'm just going to cut this off. We have no significant damage to the rest of the radio from the battery pack. There's a little bit of stuff in here, which I'm going to clean out with a little bit of isopropanol, just to try to sop up any remaining bits of the electrolyte. This is pretty well the opposite of pretty, but it'll do, and it gets our poles a little farther apart. This is just a little buck regulator type power supply, and I'm just going to turn down the voltage until we get to 3.6, 3.7, 3.6. I do know, I have checked, and this meter is accurate. And so we can then hook that in there and hook that in there and see if we have any activity. This is presumably power. No. Print. Oh, we do. Okay, you're not going to be able to see this, but we have a very dim okay, we have all right. Let's get some paper in this. So what I'm seeing is we have, if I turn it on, maybe if I shield it from the light, you can see we've got display. Does it all work? 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 10. So it's a 10-digit display. It is working. So we do have the relatively high voltage power supply is working, and we had motors turning. So let's attempt to feed some paper into it. I don't feel it pulling at all. Well, I'm going to go off camera and play. Anyway, the logic is working. I think we have a problem with not having batteries in place. So I think what I'm going to do is build a battery pack out of these three and see what that does. So we'll disconnect our power supply for the moment, push this aside, and essentially all I'm going to do is solder this cell in with these three. Now I will note that one of the characteristics of these cells is they use a single very fine wire, which I've just pulled off there, which acts as kind of a fuse. So there will be one of those in here. So the battery pack is, in its own way, kind of fused. we'll put a little bit of tape around that, and then we'll double check. We should still have voltage on this. And then we'll stick it in here and solder it onto those. So I built the battery pack. Well, built is a strong word, but taped together a few batteries and soldered them together. And we still got almost 3.4 volts on it, despite however many years these have been sitting around. So very high quality batteries that were in that phone. But we have another problem here. This black wire is fine, but this red wire is turned entirely black from exposure to the leakage from the nickel cadmium battery. So that means that I can't solder to it. This stuff won't take solder at all. So the question is what to do about it. Well, I will clip down a little farther so you can see what this looks like. It's black. I've tried to put solder on that. Here's another bit. You can see it's entirely black and oxidized, whereas the other one is perfectly fine, has tolerated being tin, sort of. Certainly not that great, but you know, this will take solder well enough that I can splice something to it. But this, well, unless I'm lucky and this last little end does, which seems unlikely. I can't even reach it with my tool to, well, we're just going to have to hope I don't pull it out of the board during this. Oh, and I did. But there we can see, right at the end, it'll take a little solder. So I really don't want to have to take the board out if I don't have to. So what I think I'm going to do is attempt, I'm wrapping this all together, is attempt to tin the end of this a little bit. And if I can, I'm going to solder it onto my battery pack directly here with some heat shrink, obviously. I'll need a little more than that. But, and so let's see if we can get it to take solder first. So after much hemming and hawing, which you won't see probably, I've got the battery pack in place. It's a bit crude, but it will work. And in fact, it does work. So there's only 3.4 volts on them right now, but if you turn it on, you get power. Display is on, and this is working properly. No. So if we then set our power supply here for 3.6 volts, it should now be able to charge those batteries, or the battery, and also give us a working cell. Now the question that we have is whether I can figure out how to get paper in it, but I think it probably is working. It's just a question of me not knowing how to do it. But now if we turn it on, we get that. It all seems to be working properly. It all makes sense. Good afternoon. It's been a while since I was playing with this. I haven't put out the video, so I'll probably edit these all together as a single one. What I did on the last section was I built a battery pack for this, which which works. And yeah, so that's what I did with it. The next step, now that we have it working, sort of, oh, there we have it on, and you probably can't see with the lights, but we got that on. Is to solve some other problems that it has. And one of them is that the printer isn't working really, and that's something we're going to have to look at. And the other thing that matters more, I think, to me at the moment, I'm not sure I'm going to be able to get the printer working properly, is that one of the numbers, and hopefully you can, let's see, maybe I'll shut off this light. Oh, wrong button. There we go. So hopefully I can turn it so you can see the display. I can't quite see. It's quite dim at the moment. But you see, 1, 2, 0, 3, 0 doesn't work, 4, 5, 6 doesn't work, 7, 8, 9. So 0 doesn't work and 6 doesn't work. I think all the rest of the buttons work. So I'll take these. I think it's probably just these. Do you think just the 4 will do it, or do you think we'll need to remove these 2 here? Probably those 2 there. And then we can get a look at what's going on. But the battery is here, right? So it's quite possible that traces along here were damaged. And we're going to have to get this board out anyway. Just a reminder that the real attraction of this is this lovely display. Now, one thing I notice about this display is it's quite dim right now. And that probably means that the voltage, there will be a power supply. You can see some of the capacitors probably related to that here, and to the 2 solenoids in a motor, I think, that drive this. I think so. I think the motor drives the head, and the solenoids control its moving back and forth. So there's one solenoid here and one here. This one seems to be working. This one does not. The motor's working, I think. So this prints this, or yeah, I think that, anyway, that one of them prints and one of them moves the carriage across letter by letter. So we do need to remove these screws. But what I was trying to say is that this display is dim and one of the solenoids is not functioning. So I wonder about the power supply down here and whether the voltage is set high enough. And I've noted on other calculators that sometimes there's a pot that controls the voltage, so we might be able to turn it up until the display looks nice. We might have separate controls of both of these. But let's deal with this keyboard first. Okay, there we go. There's the rubber domes. And that looks just fine. I don't see anything that would worry me. I don't see anything that needs cleaning on there. So we have our little gold-plated contacts. We've got our rubber domes with, I think it's carbon they put in it, but whatever they put in it to make them conductive. What's interesting is that the rubber domes, there's some extra spaces for other buttons, so there might have been another version of this with another button here and another button there. But anyway, we'll keep this in place like that to keep from damaging it. Over there. So here we have this, and do we see anything wrong with the edge connector here? That looks fine to me. Get my other glasses on and take a look. Yeah, that looks all right to me. I don't see anything that looks problematic there. That looks all right. So the hypothesis then is that when the NiCads in here went bad, they damaged something along the edge here, which is something that I've seen before. So that means that we need to get this board out. That means that we're certainly going to need to take this screw out here. Okay, I'm going to zoom in a little bit so you can see what I'm seeing. And hopefully that will be centered. So what I'm seeing is a broken trace here, right? That appears to be, the solder joint appears to be broken off of that completely. I see a bad solder joint there. Yeah, that could explain our keyboard problems right there and there. Two bad solder joints. Wonder if someone tried to desolder this. It doesn't look like it's recent work on it, but you know, that doesn't look original either. So I do wonder if someone's tried to repair this. This is where the screw comes in to hold the printer. You know what, let's take the printer mechanism out so we can see the whole circuit board. So there's the printer mechanism. This is very heavy. I just can't. It says Alps, made in Japan, patent pending. This feels extraordinarily high quality. We'll put that off to the side. The chip is a Mitsubishi chip. So we got model number EHI 032905, made in Japan. Mitsubishi chip 0576. 5th week of 1976. That makes this earlier than I thought it was. We've got no obvious adjustment for the power supply, but let's remove this little piece of tape and have a look under here. Being careful. So this has got to be the boost circuit for this display here. Those are transistors, maybe. 3 leads. Diodes. Look at the carbon resistors. No obvious adjustment for voltage, so we'll assume that we can't touch that. This says TR2, TRT, so those are transistors. These are marked E. Could they be regulators? Don't know. Diodes are all marked, resistors are all marked. No transformer here. I don't know. And there's the power in. I'll actually have to look at my video to remember what I'd done for a power supply. I can't remember. I'll put this little piece of tape back. This looks like it's essential, and we don't really need to be under here. So, what am I going to do? I think I'm going to put small tip on the soldering iron, and I'm going to re-solder all of that. Someone's got to have been in here and tried to do that. And I'm going to resolder all of those. Hopefully that'll fix the keyboard. In terms of the printer, that seems like a likely culprit, and someone's tried to fix that too at some point. So I'll do that as well. So what I'll do is I'll pause here, as I said, put a finer tip on my soldering iron, and get to that. But that's, and these seem like the logical things to try to fix. I mean, given how bad the batteries were in it, this has got to have been work that was done a very long time ago. I also might consider doing a better job of attaching this, because I just soldered it to the end so I didn't have to take the board out before. Okay, so I'll zoom in a bit. So I have attempted to resolder this here. That I've cleaned up. That looks okay to me. This is this wire, I believe, here coming through. So I think what I'm going to do is I'm going to reassemble it and see if it works. I haven't been able to get anything functioning with it like this, but that's probably because none of these switches are engaged here, right? As you can see, sorry, I'm forgetting that I'd gone into narrow view. These switches control a number of things. I won't turn it all the way because the keys will fall out, but on the calculator, and it probably needs connections here to function properly. So I think this will be my last segment on this Canon calculator, but I just want to show you where I am on it and what needs to be done. So as of the last segment, I put it together. I fixed the keyboard, and I actually had to shorten and resolder the whole ribbon cable that connects to the keyboard, which was an unpleasant job because a number of segments broke off where they form almost a right angle where it solders in here. But the keyboard's working, and I'll show you that I was able to charge up the battery, but not using the battery jack on the back. I charged it directly with alligator clips because I had my suspicions that the reason it wasn't behaving well was that the voltage was low, and the voltage was low because the batteries aren't charging, at least not properly. Now they're somewhat charged, and as you can see, the display is brighter. Hopefully that's clear, and 1, 2, 3, 4, 5, 6, 0 still works, 7, 8, 9, right? So all the buttons work, and printing works too. So let's shut it off. We'll turn print on. Oh, you know what's happened? The batteries have drained enough that now that it's not. You see the display's now gone dim. Okay, well, just trust me when I'll say when the batteries were properly charged, the printer was working. I don't have any ink for it, so the paper was advancing. It was printing. The only issue was the lack of an ink sponge for it, and I'm not sure I could get one easily. Although I don't know, maybe a rubber stamp pad inker might work to re-ink it. It might be worth a try. So the issue is, why is it not charging? And that's what I want to look into today. Here you can see where I had to resolder the cable onto the keyboard here. So we'll be very careful of that. So I think for this purpose it'll be most useful to remove the printing mechanism. Let's see if we can get there we go. So there's the plug, and with one screw and a little wiggling we should be able to get this right off, and then pulls out like that. So I think it would probably be best to lift out the circuit board here. That we can do by pushing on these tabs here, and we can have a look at the back of the board and see if we can figure out the power supply. Now, this is where I'm going to be very careful not to damage this cable, because I really don't want to do that again. We'll just clip this wire here. For the moment. That's the negative. Well, let's see if it works connected to the power supply. Yes, it does. So we have no battery at all. So I think my solution is going to be to remove the battery like that. I'll leave this, I'll put a little bit of red sleeving over it, and we can operate this with a 3.6 volt power supply. Left everything on. Something new has happened, and this is interesting. So The power supply's in. I've actually got the voltage bumped up to 4.2 volts at the moment. It's off. So we'll just zero the meter here. So this is measuring current. There's no battery. The battery's over here. Now keep in mind this thing has an internal power supply that is driving probably the whole thing, I think. So when you turn it on, you can see that it's pulling 78 milliamps, and we're getting nothing, which we were before. If we turn the printer off, we turn it on, it's still drawing 78 milliamps. I tried addressing this before by turning up the voltage a little bit higher. Oh, there we go. We had a click out of it, but we're now getting enough current that we're getting a display here. I don't know if you can see that. So something in the printer draws, you see I just did it again. I'm thinking bad capacitors again, because something's drawing the power supply down when it tries to pulse one of these, and it was working with the batteries in and charged, so that suggests that the batteries were, when they were at full charge, were acting as buffer. So we're going to open it up, have a look at the capacitors, and possibly change them. You know what? I may not have had this plugged in properly. That might be the problem too. It's very difficult to get in once the whole thing's in place. Let's take the printer out again. We can run it to the side. All right. I'll get this out of the way for a moment. Again, being careful of those, because I don't want to have to do that again. All right. And we can plug the printer back in there. So we now have the printer plugged in, but not in our way. So I've got some tins here that look to be the same size. Let's get one out. If not, I have junky ones somewhere that might be a little smaller, but we'll replace one Nichicon with another Nichicon. These are 25 volts. Which would be more than adequate. This I think says 10 volts. And unfortunately, this project is now over. That's pisser. That's the nipple from the display. The display's now dead. Well, that's a shame. That's a real shame. So I'm going to put this aside. I'll probably just toss this calculator because it's not of significant interest. Well, maybe I'll put it back together and put it in a drawer for something in the future, but yeah, can't recover from that. I just turned it over, pushed down perhaps too hard, and it was resting right on the evacuation. I guess that's where they evacuate the gas from the display. So it's now done. In fact, you can see the getters turning white as we watch. Oh well. Well, I'll try to cut something interesting out of this so you guys can avoid making the mistake that I have made. Be very careful around vacuum fluorescent displays. You can see that one's gone almost totally white. That one's still going. What a shame. All right, well, thanks for watching.